Welcome to Tomorrow Unveiled, where we pull back the curtain on the most exciting advancements shaping our future. This week, we're not just peeking into tomorrow, we're launching far beyond Earth, into the cosmos, to really dissect an extraordinary week in space. It's been a period just bursting with activity, fueled by both incredible celestial phenomena and, well, the relentless ingenuity of humanity. Our mission today on Tomorrow Unveiled is to embark on a deep dive into the latest breakthroughs and crucial developments that are rapidly accelerating our journey beyond our home planet. We'll uncover surprising facts and critical insights from the past 7 days, all rigorously cross-corroborated by our dedicated research team. So get ready for a journey. It spans from observing a mysterious interstellar comet to groundbreaking ways we're maintaining our orbital infrastructure, and even contemplating, our readiness for cosmic encounters. You're about to hear how a visitor from another star system is pushing the limits of our technology, the ingenious ways our existing spacecraft are being repurposed for new missions, and the quiet yet vital infrastructure that makes all of it possible.
It's truly been a remarkable period. It really demonstrates how far our observational capabilities have come.
Right.
But at the same time, it highlights the new sort of complex challenges that arise as we venture further out.
Absolutely. And the biggest headline grabber, it has to be our latest interstellar visitor, 3IA TESS. This isn't just any comet. It's only the third confirmed interstellar object, or ISO, ever detected in our solar system.
That's right. Third one.
First spotted back in July 2025 by the ATLA survey, this object is, well, it's unlike anything we've seen before from beyond our home star. Our research shows it's the largest and brightest interstellar object to date, initially estimated at a staggering 20 kilometers across.
Which is huge.
Huge. Later refined, though, to about 5.6 kilometers in diameter. Still, a truly monumental cosmic traveler.
And its speed alone is incredible. It's hurtling through space at what we call a hyperbolic excess velocity of roughly 58 to 61 kilometers per second.
A second, wow.
To put that simply, it means it's moving so fast that our sun's gravity just can't capture it. It's merely passing through our system.
A drive-by.
Essentially, yeah. And that confirms its origin from an entirely different star. It's set to make its closest approach to Mars on October 3rd, 2025.
Okay, Mars. Not Earth.
Right, Mars. At about 30 million kilometers, which is actually a much tighter pass than its encounter with Earth, that'll be way out at 270 million kilometers.
So we're talking about a genuine cosmic wanderer making a close-ish flyby of Mars.
Yeah.
But here's the catch you mentioned. It's perihelion.
Exactly. Its closest point to the sun. That happens in late October, but it will be on the far side of the sun from our perspective here on Earth.
Ah, so that's a massive observational challenge. It's basically hiding from our direct view right when it's most active.
Precisely. And this posed a fascinating problem. How do you get a detailed read on something so fast, so remote, and, partially obscured?
Yeah, what's the answer?
Well, the answer came through an unprecedented observational campaign. And it was notably spearheaded by NASA's newly operational Spheerix Observatory.
Spheerix launched earlier this year, right? Early 2025.
That's the one. And it delivered the first definitive compositional analysis of 3I Atlas, a huge early win for the mission.
What did it find?
It detected an exceptionally high carbon dioxide, CO2, content in the comet's coma, along with water ice. But conspicuously, it lacked carbon monoxide.
No carbon monoxide. What does that imply?
It suggests the comet was, let's say, well-baked in its home star system. It likely lost its more volatile compounds, like carbon monoxide, long before it ever reached us.
That's a huge debut for Spheerix, then. Getting such a definitive analysis on an interstellar object right off the bat. Does this initial success set an almost impossibly high bar, maybe? Or does it just prove its incredible capability?
I think it primarily proves its capability. And importantly, it highlights the power of a coordinated approach. Spheerix wasn't working in isolation.
Okay, so who else was involved?
The James Webb Space Telescope, JWST, provided crucial follow-up. It confirmed this unusual composition with really high precision.
Webb again, always delivering.
Its data indicated a CO2 to water ratio of 8-to-1. That's one of the highest ever measured in any comet, interstellar or otherwise.
8-to-1, wow.
Yeah. So that reinforces Spheerix's findings and even hinted at potential organic molecules and water vapor.
So if Spheerix and JWST gave us its chemical fingerprint, what about its appearance? What did it look like?
That's where the Hubble Space Telescope came in. Hubble delivered the sharpest visual imagery.
Old, reliable Hubble.
Exactly. It allowed astronomers to refine the nucleus size estimate and revealed a dramatically broadened coma and a growing tail. So visually dynamic.
And ground-based telescopes, too, I assume.
Absolutely. This multi-pronged approach extended right down to Earth. Observatories like the Gemini South Telescope in Chile captured striking images showing the comet's evolving coma, and the European Southern Observatory's very large telescope, the VLT, also contributed, detecting trace elements like cyanide gas and even atomic nickel vapor.
Cyanide and nickel. So the key insight from this whole multi-observatory blitz wasn't just what each telescope saw individually.
No, it was how their combined distinct perspectives allowed us to paint this unprecedented, high-resolution portrait of an object light years from its home.
It's like a masterclass in cosmic forensics, isn't it?
It really is. And the sheer speed and effectiveness of this global response, remember, it all started with that initial detection by the NASA-funded anti-LS survey in Chile.
Right, the automated survey.
Yeah, it just underscores the strategic importance of having these persistent, automated all-star surveys constantly watching for early warnings.
So the big takeaway here seems clear. Our ability to remotely see and understand an interstellar object is becoming highly advanced. Really impressive stuff.
It is. But it also starkly reveals what our research team calls a critical actionability gap.
Actionability gap, meaning
Our ability to physically touch or, intercept such an object remains nascent. We can analyze it incredibly well from afar, but we can't yet grab a sample or study it up close easily.
which leads us perfectly into our next section. Agile missions and repurposing assets, especially using Mars. Given that incredible speed, the observation challenges, and this actionability gap, it really makes you wonder, what if we could actually get closer to 3 IATs?
That's precisely why Mars is becoming this unexpected front row seat, because 3I Atlas will pass much closer to Mars than Earth.
Right, you mentioned that, 30 million kilometers versus 270 million.
Exactly. So multiple space agencies are strategically repurposing their Mars orbiters. They're essentially becoming a temporary multinational observation post. It's an incredible display of international collaboration, really.
So who's involved in this Martian observation campaign?
Well, the European Space Agency, ESA, is definitely at the forefront. They've got Mars Express and the ExoMars Trace Gas Orbiter, TGO, set to image the comet.
Okay.
NASA's Mars Reconnaissance Orbiter, MRO, is also a key player. And even China's Tianwen-1 orbiter is a potential participant.
Wow, so US, Europe, China,
Yeah,
all potentially pointing their Mars missions at this comet.
correct. It's shaping up to be an unprecedented, coordinated deep space observation campaign, a truly global effort to study this unique visitor using assets already in place.
And this is crucial, isn't it, for mitigating what our research team calls the perihelion data gap.
Absolutely vital. This Mars fleet is essential for observing 3I Atlas when it passes behind the sun as viewed from Earth in late October.
So they fill in the blind spot.
Exactly. It effectively bridges a strategic vulnerability and ensures we get continuous data collection during its most active phase. It's all about maximizing every possible moment of observation.
Okay, but this brings up the intercept challenge again. If observing from Mars is good, actually intercepting it would be even better, presumably. But you said that's hard.
Extremely hard for Earth. Feasibility studies highlight the immense propulsion needed. An intercept mission launched from Earth would demand an incredible delta V. That's the change in velocity needed.
How much are we talking?
Approximately 24 kilometers per second.
24. That's astronomical.
It's a monstrous figure, yes. It's far beyond our current rapid launch capabilities. We couldn't just decide today to launch something to catch it.
Okay. But what about from Mars?
That's where it gets interesting. A hypothetical launch from Mars orbit would only require a delta V of about 5 kilometers per second.
Only 5, compared to 24.
Right. It starkly underscores the strategic advantage of having assets already forward deployed in the solar system. Being closer helps immensely.
That difference is truly eye-opening. 5 versus 24 kilometers. And this whole situation, this near-miss opportunity, is spurring some really innovative thinking, isn't it? Like that Juno Gambit idea.
Yes, the Juno Gambit, it's an academic proposal basically asking, could we repurpose NASA's Juno spacecraft, which is currently orbiting Jupiter,
Way out at Jupiter.
and send it on a high-risk, high-reward intercept course with 3I Atlas? Now, while it seems technically plausible on paper, it's very unlikely to actually be executed. Too many risks, too complex reprogramming needed on short notice.
Sure. But the fact that it's even being seriously discussed is interesting.
It is. It reveals a potential paradigm shift, looking at our existing in-space assets not just as single mission tools, but as potentially flexible platforms that could be reallocated for targets of opportunity.
Opportunistic asset reallocation, as the research team calls it.
Precisely. And the collective difficulty we're seeing in potentially intercepting 3ILS right now, it really validates the proactive mission architecture of something like ESA's Comet Interceptor mission.
Ah, yes, Comet Interceptor, scheduled for 2029.
That's the one. It's designed specifically to loiter at the Sun-Earth L2 Lagrange point, a stable gravitational spot in space.
Just waiting.
Just waiting, essentially, for a suitable target like a pristine, long-period comet or potentially an interstellar object like 3I8LS to come along. It's a proactive approach built precisely because reacting quickly is so hard.
It makes perfect sense. Now, none of these advanced observations, these complex command sequences, the potential intercepts, none of it would be possible without a vast, often unseen architecture supporting it all.
You're talking about the communications backbone.
Exactly. We have to mention the critical role of NASA's Deep Space Network, the DSN and its international counterparts. This global network of enormous radio antennas. It's the essential link.
Absolutely essential. It transmits the commands out and receives that precious high-bandwidth data back from our most distant missions. It is truly the unsung hero of deep space exploration.
It really is. And speaking of infrastructure, that backbone is being enhanced by some significant commercial breakthroughs happening much closer to home, right in Earth orbit.
That's right. A really interesting development occurred just recently on September 3rd, 2025. For the first time ever, a SpaceX Dragon cargo vehicle.
A commercial Dragon.
Yes, the CRS-33 Mission Dragon, while docked to the International Space Station, actually performed a reboost of the station's orbit using its own Draco thrusters.
Whoa. Okay, so instead of the usual Russian Progress or the station's own engines, a commercial vehicle did the orbital boost.
Correct. It's a pivotal moment.
Why is that so significant?
Well, first, it adds crucial redundancy to ISS operations. If one method isn't available, there's another option. But more importantly, it paves the way for future commercial space stations to manage their own orbital adjustments autonomously.
Ah, so companies planning their own stations won't necessarily need government vehicles to keep them in the right orbit.
Exactly. It's a big step towards greater independence and capability for private ventures in low Earth orbit.
And the commercial innovation doesn't stop there, right? There's that startup working on return vehicles.
Orbital Paradigm, based in Madrid, yes. They're planning their first orbital re-entry mission soon. They have a small prototype called Kestrel Initial Demonstrator, or KID.
KID, okay.
It's designed to test technologies for low-cost cargo return from orbit. Their big vision is to enable monthly round-trip missions by 2027.
Monthly round trips. Like a space delivery and return service.
Pretty much. That would be a potential game changer for things like in-space manufacturing or getting microgravity research samples back to Earth quickly and cheaply.
Okay, this is all incredibly fascinating stuff. If you're finding this insightful and you're watching on YouTube, please do take a moment to like this video, subscribe to Tomorrow Unveiled, and definitely turn on those notifications so you never miss an update on the future we're exploring here.
And if you're listening on a podcast service like Apple Podcasts or Spotify, we'd be incredibly grateful if you could leave us a rating and review for Tomorrow Unveiled. It genuinely helps us reach new listeners who are curious about these topics.
It really does. Now, connecting all this back to the bigger picture of human exploration, there was that Senate hearing on September 3rd. It highlighted the urgency, maybe, of the new space race.
Yes, that hearing featured experts warning that the U.S. risks losing ground, particularly to China's methodical progress towards putting crewed missions on the moon.
So the pressure's on.
The pressure is definitely on. Lawmakers were urged pretty strongly to fully fund NASA's Artemis program and the associated Gateway Lunar Station to maintain momentum.
And these commercial advancements we were just discussing, the Dragon reboost, the return vehicles, the plans for private stations like Axiom Space and Vast's Haven 1.
Which is planned for 2025 launch.
Right. All these commercial activities are directly supporting that broader ecosystem, including the eventual transition away from the ISS, right?
Absolutely. All these threads are interconnected. Commercial EO development, lunar ambitions, deep space observation, infrastructure. It's all part of building a more robust, diverse, and sustainable future in space.
Which really brings us to some big questions about the road ahead. Thinking about 3I specifically, what does all of this mean for us back here on Earth as we observe and interact with these kinds of cosmic events?
Well, what's truly thought-provoking is how the scientific and even the public conversation around 3I Atlas has been significantly influenced by a speculative paper. It was co-authored by Harvard astrophysicist Avi Loeb.
Avi Loeb, right. Known for the Oumuamua speculations, too.
Exactly. And this paper hypothesizes that 3I Atlas might not just be a natural comet, it could potentially be an artificial probe.
An alien probe, seriously.
That's the hypothesis. It's based on what they term anomalies in its trajectory, and the fact that it's perihelion, its closest approach to the sun, happens while it's hidden from Earth's view. They argue this might be statistically improbable for a random object, perhaps suggesting
A deliberately planned survey of our solar system.
That's a suggestion made in the paper, often linked to the dark forest hypothesis from science fiction. Now, it is highly speculative, let's be clear.
Of course. But even the suggestion adds a totally new, almost sci-fi dimension to this interstellar visitor, doesn't it?
It does. And whether you find the hypothesis credible or not, its presence in the discourse moves interstellar objects out of the realm of purely scientific curiosity and squarely into the realm of, well, planetary security.
Planetary security, that feels like a big step.
It is, because it immediately leads us to consider a significant strategic vulnerability. We currently lack any kind of unified international framework for contact protocol.
Meaning, what do we do if we do detect something artificial?
Right. Or even just a framework for a coordinated threat assessment of unidentified interstellar objects, whether natural or not. We simply have no predefined security protocol for such events.
That seems like a pretty big gap.
It's a gap that 3I Atlas, regardless of its true nature, has starkly laid bare. And related concepts are now being discussed more seriously, too, like reverse planetary protection.
Reverse planetary protection, protecting Earth from something out there.
Precisely. Safeguarding Earth from potential extraterrestrial contamination, however remote that possibility might seem.
Yeah.
It's about thinking through all the implications.
So, this encounter with 3I Atlas isn't just a scientific marvel. It sounds like it's serving as a real watershed moment. A wake-up call, maybe?
I think that's fair to say. It's demanding a transition from our current reactive, sort of ad hoc posture when these things appear, towards a more proactive, architected strategy for dealing with the interstellar environment.
And what would that look like practically? What does the research team recommend?
Well, first, formalizing some kind of international ISO response framework. Basically, a clear protocol agreed upon by spacefaring nations for rapid data sharing, joint threat assessment, and coordinated decision-making if something concerning is detected.
Okay, international protocols. Makes sense. What else?
Investing seriously in a standing ready interceptor capability. Taking that Issei Comet interceptor model we discussed and elevating it, perhaps, to a permanent operational asset that's always ready to go.
So, having something parked out there waiting to launch at a moment's notice?
Potentially, yes. Or at least having the proven capability and hardware ready for rapid deployment. And underpinning all of this is the need for developing and testing advanced in-space propulsion.
To close that actionability gap.
Exactly. Programs like nuclear thermal propulsion, NTP, or other high delta V systems are becoming a strategic necessity if we ever want to realistically close that gap and gain the ability to physically reach these fast-moving distant visitors in a timely manner.
Right. It seems the broader picture here is that the ability to detect, characterize, track, and potentially even engage with interstellar objects. It's rapidly emerging as a new and critical metric of a nation's, or perhaps humanity's, comprehensive space power.
I believe so. It's less about reacting to single events and more about building a sustainable long-term strategy for actively engaging with the interstellar environment that surrounds our solar system.
So wrapping this all up, what does this extraordinary week in space mean for you, our curious listener? Well, it's shown us the incredible leaps we're making in observing the cosmos. We have these powerful telescopes revealing the secrets of an ancient interstellar visitor from another star. That's pretty amazing.
And we're also getting remarkably agile and creative in how we use the assets we already have in space, repurposing spacecraft like the Mars orbiters for new tasks.
And building the robust infrastructure, the DSN, the commercial launch and operations capabilities that's necessary for both sustained human presence and growing commercial activity beyond Earth.
But as we've discussed, it also shines a bright light on the big questions we still face. How do we, as a planet, respond to unexpected cosmic guests, especially if they seem unusual?
And the critical need for international agreements and protocols in what's becoming an increasingly complex, busy, and competitive space environment?
Yeah.
The universe beyond Earth. It feels like it's getting closer, more within reach, almost week by week with these breakthroughs. which leaves us with a fascinating question to ponder. As we continue to push these boundaries, what kind of future will we collectively build for humanity out there beyond Earth?
And perhaps more urgently, how prepared are we, really, for the next unexpected visitor that might arrive from across the vastness of interstellar space?
Food for thought indeed. We always love hearing your thoughts on these topics. Whether you're on YouTube or your favorite podcast app, please leave a comment and let us know what you think about this incredible week in space and the future of interstellar exploration. Thank you so much for joining us on Tomorrow Unveiled. We'll be back next time to unveil another corner of our fascinating future.